Hello. Hello. Am I audible?
Yes, sir. Good morning. Good evening, sir.
I'm not able to hear you. Okay. What to do? You're the only person who joined. Shall we have this in the next class? Okay, fine. So you can take some more time to solve the problems. You can meet in the next class. Hello, Abhishek.
Yes, sir.
Santosh
Hello.
also joined. Okay, so we can continue then. Three of you are here.
Okay, sir.
I'm not able to hear any of your voices.
Hello. Sir, am I audible?
Hello, sir.
Yeah, no, okay. Oh, okay.
Can you hear me?
Yeah, I can hear.
Yeah, okay.
Okay. So in the last class we did six problems. Okay, now we'll start with the seventh problem. So the seventh problem says that you're going to find the closest neighbors. So given the features of n objects and a specific object A, find the k nearest neighbors to object A. Okay. So there are n objects and there will be an object specified that which is going to be the last object. For this object, you're going to find the nearest objects. And how many nearest objects is k? You're going to find out k number of nearest objects. Okay. So this is the question. Now, so first we need to get the number of objects. You stored in n. and then you're going to enter the number of features to represent an object. So let that be m. Okay. Now there are n objects and each object will have m features. Okay, so to store all the objects, I'm going to have a list which is going to be O. Okay, and O is going to be a list of list. Okay, so and each list is going to represent an object. So for I in range of n. So n number of objects I'm going to take from the user. So I in range of n. And each object is going to have n features, right? So to store the features in a temporary list, I'll use T. Okay, and then enter feature vector 1. So here I plus 1 because I is starting from 0, right? That's why. And then I will be taking m number of features, right? So each object has m number of features. So I'll be taking m number of features. So I have to put another loop j in range of m. Okay, now I'll take the input and then append it to t. Okay, so t dot append of int of input of, yeah. Okay, so int of input of will take the input and then it will append it to t. So I will read m features of a particular object that is stored in T. So I have to append T to O. So O dot append of T. That's it. So till this statement, I have read all the inputs. Okay, till this point, this is done. Okay. Now I have to read the feature vector A. So for that, I will create a list A equal to. So to represent object A, I'm having naming it as A equal to empty list. And after that, the statement print enter feature vector A. Okay. And now again I have to put a loop for m times, right? So even A will have m features. So for I in range of m, I have to take the input and then append it to A dot append of int of input. So now I have taken A also, right? So till this point this is done. Next I have to take the k value. K is nothing but the number of neighbors I'm going to find it out which are nearest to feature vector A. Okay. So k is equal to int of input of the closest point, sorry, enter the value of k. Okay. Now next what we are going to do is, now comes the logic. Input and all are done. Okay. Now what you have to do, we have to find the distance between a and all other points. Okay, a and all other points you're going to find the distance, and after that we're going to find the shortest distances, shortest k number of distances. Okay, so for that let us create one more list d which is going to store the distance. Okay, and then we're going to sort this particular list with respect to distance. Okay, first what we'll do is we'll compute the distance between A and object 1, A and object 2, A and object 3. Like that, we'll find all the distances and store it in D. After that, we need to sort it in ascending order. While sorting, what we need is we also need the index values. Okay, so which object is coming first, which object is coming second, which object is coming third, like that we need to know the index as well. For that, what you're going to do, we are not only going to take the distance, we are also going to take the corresponding node as well. Okay, corresponding feature, corresponding object as well. Which object's distance is this much, which object distance is this much, like that we're going to keep track of the object value also, object number and the distance, like that we're going to keep track of. Okay, so let us write a separate function for calculating distance. Okay, so now, so we're going to find out how many distance values. There are n objects, so we're going to find out n distance values. Okay, distance between a and object 1, a and object 2, like that, a and object n, like that we'll find n distances. So I have to iterate for I in range of n. Okay, so d temporary. Okay, I'm going to find the temporary distance. This is nothing but the distance between a and the ith object. Okay, that is stored in di. Then after that, I'll append this dt to d. Okay, I'll tell you how to do that. So equal to calculate distance of. So I'm going to find the distance between a and object of I. And I also pass m because there are m features in each object, right? Any doubts in this? I'm going to find the distance between a and object I. Okay, this loop is going to run for n times. And suppose that I have written the distance calculation, all those things are done. So dt will hold the distance. Now what I should append to this one, d is nothing but append of, I'm going to create a list. Okay, and this list is going to contain I plus 1, which is nothing but the object number. Okay, so object number here I start from 0, whereas I need from 1 2 3 4, like that. Okay, so that object number comma dt. Okay, so this list I'll append it to d. D is nothing but the distance list. So what will this list contain? It will contain the object number and the corresponding distance. Object number comma distance, object number comma distance. Like that it will store all the details. Okay, which object and the distance. Any doubts so far? Are you able to understand?
No, sir.
Okay. Okay. Now let us write the calculate distance function. Calculate distance of, I am passing two features, right? Two objects, right? So object 1 comma object 2. So this is object A. So this calculate distance is going to find the distance between two objects. So O1 O2 comma m, number of features in each object. Okay, and then d is equal to 0. We're going to find the calculate the distance, equivalent distance only. Okay, so for I in range of m, so there are m features, right? So now what you have to do, O1 of I minus O2 of I, the whole square, plus O1 of 1 minus O2 of 1, the whole square. Like that you're going to calculate the distance. Okay, so d plus equal to O1 of I minus O2 of I the whole square. Okay. Now I have found out the subtracted square values between each features. Okay. Now I have to find the square root. D equal to math dot square root of D and then return D.
Sir, already I have used variable t for the list.
Where?
Down.
This one. Okay. Global variable. But this is okay. Will it make any difference? Local variable only,
I
right?
don't know, but
No, only if I put global here, it will make a difference. Okay, fine. Let us take a different variable, di. Okay. Mm, Okay. So just to visualize this value d, okay, the list d, let us print it and see. Five points, two features. Okay. So you can see 1 comma the distance value, 2 comma distance value, 3 comma distance value, 4 comma distance value, 5 comma distance value. Now we have a list like this. Okay. So this is actually a list of list and these are the elements of this list D. Now we need to sort this list with respect to the second parameter, right? Okay, with respect to second parameter, I need to sort. So how to do that sorting is D dot, you have the function sort, right? So if you don't pass anything, what it will do is it will do the normal sorting. Okay, so based on the number of objects, um, okay, no, okay, based on the data of the object only, it will sort. But I want this to be sorted with respect to the second value. So for that, what I should do is I should mention using which I should sort. Okay, suppose the list is of multiple variable varying length. Okay, so at that time what I will do is I'll just put key equal to length. Okay, sort of key is equal to length. Okay, so this length is actually a function, right? This will apply on all the list values and then it will give a value, right? So length of list one, length of list two, like that it will apply. So like that, you're going to write a function. So that function using which you're going to sort it. Okay. So this is very simple. You need to just write a lambda function. Lambda x colon x of 1. That's all. So what this function do is, see, this is going to return a function where x will hold each and every element of the list D, right? So the element of list D is what? These are all the elements of list D. So if you take the first element of list D, so what is the first element's value at index 1? It is 7.07. Okay, like that. If you take the second element, x1 is what? 5.56. Okay, we take the third element, x1 is x of 1 is nothing but element at the first index, right? Okay, so 1 2 3 and all are in the 0th index. The distance values are all in the first index, right? So it will take all the distance values, and based on the distance values it will sort. Okay, so let me run the code after making a sort. Now we will understand. Okay, now can I see the data is being sorted with respect to the second element. Okay, so this is how you will write the sort function corresponding to whichever element, according to with respect to whichever element you want to sort. You can do a modification. Okay, now I have sorted. So after sorting, I need to pick up the k closest neighbors, right? So just print the first three. For I in range of k, print. Now d is already sorted, right? So d of I of 0. So 0 means the first value, right? First value is what? 5 4 3 2. These are the object numbers. Okay, now I will remove this printing. Don't want this printing. Save. I validate it directly. Okay. Closest points are, forgot to print. Yeah. So 5 4 3 are the closest points. Any doubts in this?
So please repeat this last print statement di of 0.
Okay. So if you see, d is nothing but okay, d of okay, this is the list D. Okay, whatever you're seeing here is list D. We're printing element by element. All the elements are being printed. So here, if you can see that 0th element is the object values, object numbers actually, right? And this is the corresponding distance. So we just need the object numbers. So first three object numbers we are taking. For that only we are iterating for k number of times. And then we are printing. Okay, D is already sorted, right? So I will be ranging from 0 1 2. K is 3, right? 0 1 2. So d of 0 of 0. Okay, this is d of 0, and in this 0th element is 5. So 5 will be printed. So if I is 1, this is d of 1.
Okay, got it. Thank you.
Okay, fine. Yeah, now we'll go to the next problem. Okay, so this problem, this is the first iteration of the hierarchical clustering. So hierarchical clustering starts by treating each observation as a separate cluster. Okay, so if there are 4 objects, then it means that there are 4 different clusters. Then it repeatedly executes the following 2 steps. So what are the steps? First one is identify the 2 clusters that are closest to each other. Okay, and then merge the 2 most similar clusters. This continues until the clusters are merged together. Okay, finally you should get a single cluster. Till that point you have to keep on doing these 2 steps. So first step is what? Identify the 2 clusters that are closest to each other, closest together, and merge the two most similar clusters. Which means what? The 2 closest clusters have to be merged together. Yeah. So now let's start solving. The first one is enter the number of objects. See here actually what they have done is there will be a small modification in the output. I'll tell you after this. So here I think they have considered the smallest, there is the shortest distance and then done the clustering. But actually we have to take the median and then do the clustering. I'll give you that step also. There might be a small difference with this output. If there is any difference, I'll make a change in the output also. Now I'll show you how to do this, solve this problem exactly. So first we are getting the number of objects. Enter the number of objects. Enter the number of features to represent an object. And then the similar way, okay, like the previous problem. So let us take object. So this is an object list. And then now we'll run a loop for n times. So there are going to be n objects. So run the loop for n times. And then each object is going to contain m number of features. Okay, so temporary list I'll create to store the features, and then after that I'll append it to O. Enter feature, okay, and then corresponding numbers will be printed, and then I have to put a loop for which will run for m times. Okay, j in range of m, and then t dot append of int of input. Okay, so this will take all the features of the corresponding object, and then I have to append this temporary list to O. Yeah, till this point it is done. So we have taken all the features, and we have O here. Okay, now what you have to do? You have to find the distance matrix. So again, so we are going to find the distance matrix means what? Between each and every feature, we're going to find the distance matrix. Sorry, distance values. Okay, so for calculating distance, let us write the function. It is the same as the previous program only. We'll write the distance calculation function here. So you'll get two objects, O1, O2, comma, M. Then D is equal to 0 for I in range of M. D plus equal to O1 of I minus O2 of I the whole square. Okay, and then D is equal to math dot square root of D return D. So distance calculation is done. Now I'll create a distance matrix list. This is going to be a list of list. Okay, to store all these values, I created this DM. Okay, DM is going to store this all these elements. Now what? See, all these values are nothing but distance between each and every pair of objects, right? Okay. So I need to write a nested loop for I in range of n for j in range of n. Okay. So now every row I'll calculate individually, and after that I will add it to dm. Okay. So t is equal to empty list t dot append of calculate distance of. Okay. So now which is object 1? The ith object. The object 2 is jth object. Okay. So passing two objects. So O of I, comma O of j, comma m. M is the number of features. Okay. So passing object 1, comma object 2, and then the distance. So this calculate distance will return the distance between object I and object j. That I am appending it to t. And after that, what I will do after coming out of this loop, I will append it to dm is equal to, sorry, dot append of t. Okay. Now I have created the distance matrix. Now I have to print the distance matrix. For so I can put a nested loop itself. Range of n. So there are going to be n cross n distance values, right? Okay. For j in range of n. Okay. And then print percentage point 2f, comma, sorry, percentage dm of I of j, comma, end is equal to space and then empty print. So this will print all the features. Okay, so now let us test the code till this point. Any doubts so far? As of now, we have just calculated the distance matrix. Till this point, we are done. Any doubts so far?
No, sir.
Okay. 4 objects, 2 features, 1 0 6 7 7 minus 8 2 1. Okay, so till this point it is done. We have found out the distance matrix. Okay, so now next what you have to do, we have to find out the smallest the closest pair. Okay, next you have to find out the closest pair. So this is the distance matrix, and among this you can see the closest point is 3, closest distance is 1.41, right? So now I have to find out 1.4 is the closest point as well as the corresponding objects. Okay, object 0 as well as object 3. Okay, that forms the closest pair. Okay, object 0, object 3 corresponds to the closest pair. Okay, so I'll write COCLO, closest object, is equal to, I'll write a function for this, closest pair. So I have to find the closest pair from this distance matrix. I can pass n, where I have the number of elements, number of objects. Okay, and this function is going to return um, the two objects which are closest to each other as well as its distance. Okay, so in short, I just write the template here. What it is going to return? It is going to return a list. This list is going to contain the two objects. Okay, so the object 1 which is 0 and object 2 which is 3, and then the distance 1.41. So this is what the closest pair function is going to return. Understood? Now we're going to write the function in such a way that this calculates the closest distance, closest pair, and then returns this particular list. Okay, now let us go to the function. Okay, dm comma n. Okay, so now we can see that it is enough that we concentrate on either the left half, okay, that is the lower triangle, or the upper triangle, right? We need not iterate over the entire matrix. Got it? So it is enough that we iterate over either the left half or over the right half. Even the diagonal is also not needed. So if we include the entire thing, what happens? 0 becomes the smallest pair. So all those complications are avoided if we concentrate only on the left, like lower triangle or on the upper triangle. So now let us concentrate only on the lower triangle. I'm going to write a code so that it concentrates only on the lower triangle. Okay. So in this lower triangle, what is the lower triangle? We have 8.6, the first line. The second line we have 10, 15.03. The third line we have 1.41, 7.21, and 10.30. Fine. So I'm going to concentrate only on these points, these distance values. Okay. So now what I'm going to do is I'm going to assign the first point is there, right? 8.60. This as the smallest point, and then proceed with the logic. So because I need some initialization, right? Okay. For that purpose, I'll write okay, d, I have not used any, right? Okay, so d is equal to, so what is this value actually? This is 1 comma 0, right? So dm of 1 of 0. and then the x and y value. X is going to represent the row number and y is going to represent the column number. Okay. Now let us make it this way. The first value x is going to store the smaller value and y is going to store the larger value. Okay. Why? Because I'll be removing. So if I find the closest pair, suppose that 0 comma 3 is forming the closest pair, what I should do? I should remove the third object, right? Actually I should remove both the objects and replace with one object, but what happens here is actually I'll remove the farthest object. Okay, farthest object means here with respect to index. Third object is the farthest, right? Okay, zeroth object, let it be, and I'll remove the farthest object, and then I'll be replacing the zeroth object with the median between the first object and the zeroth object and the third object. Okay, that is what we're going to do. So for that purpose, let x store the smallest value. X is equal to 0 and then y is equal to 1. So I'll repeat again what I told now. See here, the I'm concentrating on the lower pair, right? Lower triangle, right? So here in the lower triangle, this 1.41 is going to store is going to be the smallest distance. The corresponding index values are 3 comma 0. Okay. So what I want x and y to store is the actually x and y should store the closest objects. So 3 and 4 are 3 and 0 are going to be the values of x and y. But what I want to store in x is the smallest among 3 and 0. Okay, and y has to store the largest among 3 and 0. Why? Because I am going to eliminate this yth object, and then the median of xth object and yth object is going to be stored in xth object, stored as x object. Understood? See here, if you are combining A and B, what happens after combining A and B? This will become a single cluster, and then the center point acts like the representation of these 2 points, right? This 2 becomes a single cluster. Means what? There should be some representation point. That point is nothing but the midpoint. So what is happening here is we are removing 2 points and it is replaced by a single point. So what we're going to do is that single point is going to be A, and then we're going to remove this B from the cluster itself. So this A will be replaced by the midpoint of A and B, and then B will be removed from the clusters itself. Did you get
Got it,
this?
sir. Got it.
Okay. Yeah. Fine. That's why X is the smaller value, Y is the larger value. So now I want to start the loop, and I is going to run for n times. So there are n rows n times, and then j will run only for I number of times. Okay, I in range of n for j in range of I. Why? Because it is enough that I go till this point, right? So first time I value is 0. So this j loop will not run at all, because in the first row I did not consider any values. So if it comes to second iteration, I is equal to 1. Okay, so it will run for once, right? J loop will run once. It will take this value 8.60, right? Like that goes on for each and every step. Now, if I find that dm the current distance, okay, dm of I of j, if it is less than, we're going to find out the smallest distance, right? So if it is less than d, so replace d with dm of I of j, and after that x and y should be updated, right? So now among I and j, which should be the smaller value?
J.
Yeah, j is going to be the smaller value. So x is equal to j, and then y is equal to I. That's all. Okay, once completion of these two this entire loop, D will be holding the smallest value, and then X will be holding object 1 and Y will be holding object 2, indices of corresponding objects. Okay, and this is the format I told, right? First the smaller index, second the larger index, and the distance. So we have to create a list in the same format and then return. So return the smaller index is X, larger index is Y, and then the distance. So this is the functionality of closest pair. Okay. Now I have the closest pair with me. Okay, I found the closest pair. So this is actually an object. CLO is the object. Now I am going to eliminate object 3, and then this zeroth object is there, right? It's going to be replaced with the median of object 0 and object 3. Okay, the center point of object 0 and object 3. Fine. Now let us find the median. Okay. So now we're going to create a list of new objects, right? So let us name it as NO, new object. Any doubts? Okay. So this new object is going to hold the new after combining object 0 and object 3. Okay, it is going to hold the objects. Okay. So now, so previously there are n objects, right? So I'm going to iterate over all the n objects for I in range of n. So if I is going to correspond to the index of each object, right? So if I is equal to 0 or is equal to 3, I have to do some some logic has to be written. Apart from this 0 and 3, if it is any other value, then I can directly take, see, I am combining A and B. Okay, so A and B will form a single cluster, whereas all the others are remaining the same, right? Okay, so I can just take this and put it in new object directly without doing any modification. I'll take C, D, E, F and put it in new object. Whereas this A, B alone, some operation has to be done. Okay, so for that only, if I is not equal to, so what is this first element? CLO of 0, right? And I not equal to CLO of 1. Okay, so if I is not equal to 0 and I is not equal to 3, okay, both the cases, then what I should do? I can directly take the ith object and then put it in NO, new object. Any doubts in this? Any doubts?
Once again,
Okay. See here, this closest pair is returning these three values. Okay, the 0 and 1 are the objects to be combined. For example, let's say A and B are the objects to be combined. The 0 and 3, sorry, not 0 and 1, 0 and 3. And so what we're going to do is we're going to remove this 0 and 3, and this 0 is going to be replaced with the median of, that is the centroid of 0 and 3, and then 3 we're going to remove it from the list itself. Okay, so if previously if there are n objects, in this new object list there are going to be n minus 1 objects. Understood? Okay, so why? Because we are combining two objects into a single object. That one will get reduced now. So that is what we're going to do. And here what we're doing is Apart from this A and V, all the other points are there, right? Those can be taken without any modification. Directly you can take these elements and store it in new object. Only if it is A or B, we have to do some calculation. That we'll do it in the else part. Okay. So here we are just finding that if I is not equal to 0 or 3. Okay, it should not be 0 as well as it should not be equal to 3. Then what happens? We'll directly take that object and storing it in NO. Understood? Yes, is it okay?
Yes, sir. But I have a doubt that 0 and 3 are the indices or indices values.
0
I
and
mean-
3 are the object's corresponding index.
Okay.
See here we have found out one, yeah. So this 1.41 is the smallest, shortest distance, right? So this distance is between object 0 and object 3. So here we are writing 1, 2, 3, 4. But whereas in the respect to index, it is 0 and 3 only, right? Okay.
Yeah, okay, sir.
Okay. So else if, so if it is 3, if I is equal to 3, what should I do? So don't do anything, just continue.
3 elif I is equal to CL of 3 down elif.
Sorry,
You said elif I is equals to
CLO of
3.
1.
1. Okay.
This is 1, right? Index with respect to index. So if it is equal to this one, what I should do is, if it is equal to the first value, okay, if it is equal to 0, then what should I do? I should find the centroid of these two objects and then like replace it in the corresponding location, right? Elif I is equal to CLO of 0. Okay, so NO dot append of, I will write a function to find the centroid, okay? Find centroid of, between which and which object I should find? Between 0 and 3. Okay, so that is there in O of CLO of 0, okay, comma O of CLO of 1. So this find centroid is going to find the centroid of, centroid is nothing but the midpoint. Okay, if it is two objects, then the midpoint is called the centroid. Okay, so now the first object and the second object. So now, any doubts in this? Are you able to understand? So you're going to find the centroid, center point of the first object and the second object, and then we are going to replace it in place of 0th position. Okay. So I have to pass M also, because how many features are there, I should pass, right? M. So find centroid of object 1 comma object 2 comma M. Okay, so here what I would do, I'm going to write a new point would be created, P. Okay, that point is nothing but the midpoint of object 1 and object 2. Okay, so there are M features in both the objects. So for I in range of M, okay, so P dot append of, so midpoint of first coordinate, midpoint of second coordinate, midpoint of third coordinate, like that it goes on. Okay, so midpoint means what? O1 of I plus O2 of I divided by 2. That's all. Okay, and then return P. So this is how you will find the centroid point between 2 points, 2 objects. Okay, if there are multiple objects, then you have to find the average. So it's nothing but finding the average of corresponding like coordinate values. Okay. So any doubts on this? There are actually m features. So I am iterating for m times, and then each and every corresponding like coordinates are we are finding the average, right? Okay. So that centroid point will be replaced in place of the zeroth location. Okay. So now we have the new object list. Okay. So after finding the new object list, let us find the new distance matrix. So now this old distance matrix will not be of any use to us hereafter. So we can just replace this old new matrix, distance matrix with a new distance matrix. Okay. dm is equal to again empty list. The same thing we are going to do. Okay. So now how many objects are there in NO? In new object list, how many objects are there?
N minus 1.
Yes, n minus 1. Because we eliminated one object, right? I in range of, so we can update n value also. Okay, so n is equal to n minus 1. Okay, so after this, what we're going to do? We're going to find the distance matrix. Okay. Again, t is equal to empty list for j in range of n t dot append of what was the function name? Calculate distance. Calculate distance of now no of I comma no of j comma distance between object 1 object 2 comma m, right? This is what we passed, right? Yeah, object 1 object 2. Okay, and after that dm dot append of t. That's all. So we have calculated the distance matrix, new distance matrix. Now we can print this. Okay. Now this one has to be printed. Matrix after first cluster. And then you have to find the, so print the distance matrix. So for I in range of n, for j in range of n. Okay, and then print percentage point to f percentage dm of 1 j ij comma end is equal to space and then an empty print. Yeah, so till this point we are done. Okay, then what you have to do, you have to print the last statement. So this we have kept track in COL, right? CLO, closest object, right? So using that you can print the last statement. Print v merge objects %d and %d, both are integers, into a cluster with distance percentage point to f. Okay, and then here percentage. So here, what is the first point? It is CLO of 0, right? So using that CLO itself, we can print all the necessary details. CLO of 0, comma, CLO of 1, comma, CLO of 2. Okay, CLO of 0 is first. Okay, actually you have to put +1 because their index values are there. You have to print the object number, right? That's it. So CL of 0 plus 1, which is nothing but 0 plus 1, 1, 4. Okay, and then 1.4 on 4. Okay, so that's it. This is the logic. Now let us see whether we're getting the same output which is mentioned in the sample. What is the mistake? Valid syntax. Okay, star square. Four, 3, 1, 0, 6, 7, 7, -8, 2, 1. Kill down. What happened? We'll run it again. 4, 2, 1, 0, 6, 7, 7, -8, 2, 1. Yeah. So actually, this is close to the answer, but a small deviation is there. Okay, that is because we found out the midpoint, right? That's it. Okay. So I will, if I'll make the changes in the sample as well as the test cases, and after that you can submit it. Any doubts in this? This is the first iteration. Any doubts?
The code. Can you show me the code?
Which part of the code?
I mean, from the beginning. I'll take a snap. Mix. Next. Thank you.
Okay. Now the last problem. Now we're going to make the entire implementation. So given the features of n objects, write a program to simulate hierarchical agglomerative clustering algorithm using single linkage method. Okay, so now let us start. And here we can see that, so let us first understand the sample input output, then we can go to the problem. So first they are giving the number of students. There are 6 students. Okay, these are the names of the students. And then they are taking 3 marks. Okay, number of tests 3. So this is going to be the number of features, right? So here we're taking 3 marks and all the inputs are done. And after that, okay, we are printing the distance matrix. After putting the distance matrix, this is the first iteration. So the minimum distance they are finding out, and then between which and which student the minimum distance falls, that also they are finding out. So after that, what they are doing, they are combining these 2 students into a single cluster. Okay, and this is the output after the first iteration. Okay, fine. And and this is the distance matrix, updated distance matrix after doing the clustering, first clustering. And among this, they are finding out the next to smallest value. Okay, so this is going to happen repeatedly, and we can see every time what happens, the cluster keeps on building up, right? As well as if one cluster is removed, the other cluster builds up. That is what is happening. If you see here, the next step is the second iteration. So 2 more got clustered together. Okay, in the third iteration, another 2 more got clustered together. And this, you can see, this is the 3 clusters. Initially there are 6 clusters, it got combined to 3 clusters. And after that, what happens? Among this, we're going to find out the minimum value, and that would make the cluster with 4 values. Okay. Now what we're going to do is we're going to construct like so that cluster formation is going to be another list. Okay, so what are the elements of the cluster is going to be represented in a cluster. Sorry, in a list. Okay, so the structure is going to be like we're taking the names, right? Okay, so and we're going to represent Arun falls under which cluster, Sasi falls under which cluster, Dana falls under which cluster. So we'll be naming the clusters also. Okay, so it becomes easy, right? So what happens? Cluster 1, what are the elements? Cluster 2, what are the elements? Like that we can easily identify. For that purpose, the clusters are going to be in the form of a um, list of list. Okay, I'll show you how it is done. First, n objects. Okay, so now we are naming the clusters, naming each cluster. So I'll write CL, which is the cluster, is equal to an empty list. So we're going to take 6 inputs, that is n inputs. So I in range of n. Okay, and then let me take it in a temporary variable t is equal to input of. So this t will hold the name initially, and then I'm going to take this as an element of cluster, put it as an element of cluster. So what I should do, cl dot append of, I'm going to create a list. Okay, and then so inside this list, the first value is going to be the cluster number. Okay, so cluster number I can name it as if there is no like printing of the cluster number, so we're just going to print the values of the cluster. So either we can start from 0 or 1, is as per your wish. Okay, if it is 0, then we can directly map it to the index. So it will be quite easier if you start with 0. If you start with 1, then again you have to put -1 everywhere. Okay, for that I will put I itself, which will start from 0, comma, I'm going to create a list. Why a list? Because this again going to be the list of students, right? So initially in the cluster 1, there is only one student, but there is a chance of building more students in that cluster, right? T. Any doubts on this? So the CLSC cluster actually, okay, and this contains I, which is the cluster number, comma, a list which contains the initial cluster values. Okay, so it will be like 0 Arun, 1 Sasi, 2 Dana, 3 Amar. Okay, like that it goes on. Any doubts on this? So if I want to add more elements to cluster 0, what I would do? I would just append it to this list, right? Very simple. Are you able to map this with the overall logic?
I got it.
Okay.
It simply assigns to like Arun is at position 0 and then Sasi at
Yeah,
1.
yeah. Correct,
Okay.
correct, correct. So later on we can like build more elements to this list. That's fine. Okay. Okay, fine. So next we are going to get the features. So features, I will mark it as O itself, objects. And before that number of test, M. Okay. Now next what we're going to do is we're going to get the features. Now what you have to put a loop. There are n objects. So for I in range of n, so print. So I want to print Arun in place of 1. So what should I do? Marks of what?
Percentile is
Okay. So what should come?
I.
In place of a-
Sorry. T, I of T, I of CL of T, yes, no? CL of 1.
CL of
1
I
of 1.
of 1. 1 will be actually a list. Okay. So we can also
And
write
also in that it's a list. Okay, I of okay, I of 0.
correct. So CL of I is the ith cluster. In that ith cluster, I'm taking the
First.
first element, which is nothing but list of names. In
Yeah.
that list of names, I'm taking the 0th element
Okay.
because as of now only one element is there. So I'm only one will be printed. Okay. Now next, what I have to get the features. So for j in range of m, temporary list, t dot append of int of input and then o dot append of t. That's all. So till this point it is done. Now next what you have to do, you have to find the distance matrix.
So distance means x1 y1 minus x1 y2 minus x2 y3 minus x3 whole square.
Hmm?
Like we have three elements now, sir.
Yeah.
So we need to do like x1
We have to
y1.
put a loop. Yeah, correct.
Okay.
Mhm. So dm for I in range of n, temporary list j in range of n, uh, t dot append of calculate distance of object 1, which is o of I, comma o of j, comma m. Now calculate distance function. Def calculate distance of o1 comma o2 comma m.
So I have a doubt.
Yes.
Like we are having 3 marks. Three tests and 3 marks we are there. 82, 83, 85 like that. So we need to subtract 82 minus 67, 83 minus 70 and 85 minus 55 like that.
Yeah, correct.
Then we are having only two objects, O1 and O2.
No, object 1 is what? See, object 1 is 100, 98, 95. Object 2 is 22,
Okay.
25,
Yeah,
16.
got it. Before problems, we have only two variables, so I got them.
No, in the previous problem also, we
Yeah,
took the,
similarly, yes,
uh,
sir.
took the index, we took the number of features also. There only.
Yeah, I thought of like that. Okay.
Okay. So d is equal to 0 for I in range of m. D plus equal to O1 of I minus O2 of I whole square, return math dot square root of D, import math. Yeah, now distance matrix is done. Okay, till this point it is done. Now next what you have to do? You have to find out the minimum distance and then the two clusters that are combined together into a single cluster. Okay. Next is what? Minimum distance. The same closest pair you're going to find out. Okay. CLO is equal to closest pair. So for this closest pair, you need to pass the distance matrix as well as n. Okay. Def closest pair of distance matrix comma n d is equal to the same concept. Okay, so dm of 1 0. Okay, 1 of 0 and x is equal to 0 and then y is equal to 1. So for I in range of n, for j in range of I. Okay, so if d is less than dm of
I.
I of j, d is equal to dm of I of j, x is equal to j, y is equal to I. Return x comma y comma d. So we have found out the closest pair. Next, okay, next they are printing this and then they write distance matrix. Okay, so let us do the same. Print minimum distance is percentage point two f and the new cluster found is. Okay, let us do the cluster combination first and then we can come to this step. Cluster combination. Okay, for new cluster, right? So NCL I in range of n. Okay, so if I is not equal to CLO of 0 and I is not equal to CLO of 1, NCL dot append of CL of I. Okay, if I
CL or CLO?
here CL only.
Okay.
Ith cluster I am appending to new cluster.
Yeah, but you have taken what is CL, Saila?
CLO is the class new closest pair.
Okay, but append of CL of I. CL or CL?
CL is the cluster. See, initially took all the clusters, no? Here. This one.
Okay, CL. Yeah, got it. Okay, sir.
Okay.
No, I
So we
didn't
need to
take another.
combine the features also. Okay. We have to combine the features. Now we are combining the clusters. Then we can combine the features.
Okay.
elif I is equal to CLO of 0. If it is equal to 1, continue. Else if I is equal to CLO of, actually
Centroid.
this can be put in else also, but still that's for clarification. I'm writing in else if.
Okay. Centroid.
No, here not centroid. We're going to combine the clue clusters here. Okay, so
But
NCL,
here we need not to do any.
that also you have to do.
Okay.
Okay, first let us cluster of I will put it. Okay, and then NCL of the name I have to add, like the, see here, suppose if this is giving me, let me take the same 0 comma 3 comma 1.41. So 0th cluster and 3rd cluster I'm going to combine. Okay, so 3rd cluster there is a name, 0th cluster there is another name. So I have to append all the names of 3rd cluster to the names of the 1st cluster. So now how to take the name list in the 0th cluster?
CL of NCL of CL
Of NCL of I of yeah, I is CL of 0. Okay, so you can put I also. In that, the first one dot extend of CLO of 1 of 1. Understood this? I'll explain this. See,
One
now
second.
I have taken this cluster. This is nothing but the 0th cluster. Okay, let us
But
take this
before
example.
that, you have mentioned if I not is equals to CL of 0, you are appending that same thing.
This is not equal to, no?
Okay, both.
Both are not equal.
Yeah, but if I not is equals to CL of 0, and in such conditions only we have to append CL of I.
There you are not
Okay.
combining the clusters here, no? See, we are
Okay.
combining 0th cluster and 3rd cluster. So if it is a 1st cluster or a 4th cluster or 7th cluster, I should not do any operation. Directly, I have to consider the same clusters. That's what is happening here. If it is the 3rd
Okay.
cluster, I'm just omitting it. That is what is continue. If it is a 0th cluster, I am taking all the values of the 3rd cluster and storing it in 0th cluster. See here, suppose if Arun and Dana are going to combine. So I should take the value of Dana and then store it in Arun, right? Okay, so I should take Dana and store it. So this cluster become Arun comma Dana.
Yeah, got it.
Okay, so that is what is happening here. So extend. So this is NCL of I of 1. This is actually the list of names. Dot extend of list of names in the 2nd cluster. That is the 3rd cluster. Okay.
Okay, sir. Yes, sir.
Yeah. So now this we have combined the clusters. Now we have to combine the features also. Okay. So I can write it here itself. So I'll write it one by one here itself. Now the features are stored in which O, right? Okay. Features are stored in O. So I'll write new object NO. NO dot append of O of I. Okay, and after that this is continue, and then here I have to find the centroid of um, CLO of 0 and CLO of 1, and then store it in NO. Okay, so NO dot append of find centroid of these 2 points, O of CLO of 0, comma O of CLO of 1. Okay, find centroid, and that will be appended to NO. Now find centroid. O1, comma O2, comma M. There are M features. I should pass M also. Comma M. So here
Any
find
variable?
centroid. Yeah,
Yeah.
centroid object. Okay, so temporary T is equal to for I in range of M, T dot append of. Okay, let me not take T. O. O not append of O1 of I plus O2 of I divided by 2, and finally return O. Okay, yeah, so we have calculated the new object. Now we can subtract N. N is equal, okay, after printing let us subtract. N is equal to N minus 1. Okay, now next what? Now we have to print these values. Okay, minimum distance is the distance value, and the new cluster formed is, okay, I have to print the new cluster value. So that is inside a list, right?
Yes, sir.
Formed is. So from where we should take the new cluster?
From closest pair.
Yeah,
No, no,
closest
no.
pairs,
Yeah.
0th value, right?
Yes, sir.
Then I have to use comma and all. What to do? Okay, formatting and all we will take care of it later. So I'll just print. Okay. The list only, no? Here is I can do. Percentage for list I cannot do. Okay. Print. So that corresponding list I have to take from NCL. Okay. NCL of CLO of 0 of 1. of see here I put open bracket. I should close now. That's why I'm putting a close bracket here. And then in between, I'm printing this list. Okay. And then
But we
here,
have one. But we
yeah,
have flower basis now.
flower instead of flower basis, I put square bracket. I'll change this later. Okay. So this
Okay.
list will print the square brackets. No. Percentage. The distance value from CLO of 3. Sorry, 2. So this distance value. Okay. And then now let us print the distance matrix. For so we haven't calculated the distance matrix now. So n dm new distance matrix is equal to, so you have the new features objects here, and n minus 1 you can do it here itself. For I in range of n, for j in range of n. Okay, temporary t is equal to t dot append of calculate distance of
Oh, one of.
no no of I comma no of j comma n, new distance matrix dot append of t. And then now we're going to print this distance matrix for I in range of n, for j in range of n, print percentage point to f percentage new distance matrix of I of j comma end is equal to space print, and after that you have to print all these clusters. Okay, so for I in range of n, clusters are in ncl, right? Okay, so print cluster percentage d percentage percentage I plus 1.
I,
I can do it directly. Cluster comma
see.
I plus 1 comma ncl of I of 1. Okay, this is the cluster number, and then 1 will contain the names, right? That's what.
Sir, spelling CLUST. Yeah.
Yeah.
I mean, it makes.
That's all. So this is the first iteration. Let us see whether it is working correctly or not. Giving the inputs only it's a big problem. Number of students 6. Why is enter the names? Not there. Oh, no.
So otherwise directly you can validate
Yeah, correct.
because such long.
Index out of range. Line number 12. Closest pair. You didn't append this dm dot.
Yeah.
What is the distance matrix? Are we getting the correct distance matrix? Let's see here.
Minimum distance value we got 166.32.
Maximum distance, yeah, finding out.
Yeah. It's D should be less than D should be
Yeah,
greater.
yeah. Where is it? D is greater than.
Yeah, it's now correct.
Okay.
The output is without commas.
No, that I will modify it.
Yeah, okay.
Okay, fine. So without
This is
comma
for
as
the
well as
first iteration, sir.
this is for the first iteration. Now, how to do it for the other iterations is we need to run this loop. Okay, so there are n features, no? So you have to run this for n minus 1
And
times. So from where we should start the loop is that is the thing. Okay.
yes, sir.
So 1 second. 1 minute wait. Let me switch on the light.
Okay, sir.
Only we both are there. 1 minute. I'll come. Yeah. Okay. Mm, all these are initial distance matrix. Closest pair. After finding the distance matrix, you are finding the closest pair. Okay. So from here you have to put the loop. So I'll just mark it here. And then inside, okay, let me write the loop also. And the what variable to keep for loop. And the n value also will be changing now frequently. Okay. So loop LPV. It's a loop variable. Um, for which value, which variable I haven't used at all. Z. Okay. Range of ITR minus 1. And here, what we should do? Yeah. So we should update all the old ones to new ones. Okay. So here distance matrix is fine. And after that, the new distance matrix will become the old distance matrix. So dm is equal to new distance matrix. Likewise, cluster is equal to new cluster. And what other news are there?
Already we are using
What?
NCL.
No, that's what.
Okay, okay. Yeah, okay,
It's
okay.
updating the
But
old cluster with a new cluster.
new cluster.
And object O is equal to NO. Anything else? That's all, no? And this will keep on iterating for n minus 1 times. That is what is here. Okay, I think this is fine. First Amardana, then Arun Giri, and Sasi Peri, and then Arun Giri, Amardana. Okay.
What is the difference?
The order is changing. Okay, we'll change order. And then all combined. Yeah, correct. That's it.
But we got difference, no, sir. Minimum distance is 39.41 in sample.
Where, yeah.
And also next minimum distance is 112.19. Here it's different.
Wait. Let us check the last distance. Yeah, actually, I think some wrong.
Error in the sample.
Calculation. Yeah. See why? Because see the distance value should change from
First
the
two
previous
values are
product.
correct. Yes.
I will make modifications in this. Okay.
Okay, sir.
I will go through the code once again, whatever I have written. If I find
Okay.
that everything is correct, then I'll make modifications. So this is hierarchical clustering. Okay.
So, but where do we use this application exactly?
Yeah. So see distance-based clustering. So now we see here
Like real time.
real-time clustering. So this is just finding the similarity between two objects. Between
Okay.
the objects. See, actually here you can see that the distance between this cluster and this cluster would be very large,
Yeah.
right? So we can keep a threshold and then say that if the distance crosses a particular threshold, then we can stop there, and this would be optimal cluster. Clustering means what is, we are trying to
Okay.
segregate two uh, like two groups actually. So we are
Okay.
trying to form different groups based on the distance here. That's it. So this is one of the machine learning clustering algorithm.
Achha. Okay, sir.
Okay.
So
Okay.
can I have this code? I
Yeah,
will
yeah.
take a snap.
Yeah.
I just try one. I took next one. Next.
That's all.
From 30.
Oh, sorry. This is number 9. Sorry, program 8 address.
Yeah, next. Hello.
Yeah, done. Then that's it.
Okay. Okay, sir.
Okay. So just try it and submit it once. I'll check your output also, and if there is any modification, I'll change it. Once you submit, you can just send me a message. Okay.
Yeah, done.
Okay. Fine.
Okay, sir.
Yeah. Thank you.
Thank you.